Hi, this is Maggie. In this video we're going to talk about the observer design pattern. If you haven't looked at the Picture Mover program, I recommend you watch that video and look at that code, and then return here, as we will work with that program in this video. The observer design pattern is one of the patterns described in the book published in 1995 called Design Patterns, written by the authors sometimes referred to as the Gang of Four. If you're planning on working as a software engineer, I recommend you read this book and any books you can find on using these patterns in the language or languages in which you develop. This association class diagram shows the objects, or you might think of them as object roles, in the observer pattern. There are two. The first is the subject, and the second is the observer. An observer is an object that registers with a subject so that it can remain synchronized with the state of the subject. When the subject changes, it informs all registered observers so that they can update their state. This pattern offers a generic way for the subject to inform observers that they must update without the subject knowing anything about its observers, including how many there are or what classes they are. If you imagine the example described in the text, a graphing program with synchronized table, graph, and animation, the table might be the subject, and the graph and animation might be observers. If a value in the table is changed, it notifies its observers, and they do the work of obtaining the state information they need from the table so they can update appropriately. We could add another observer to the program and it wouldn't alter the subject's functioning at all. It would still send messages to all of its observers when it updates. This is a sequence diagram showing the messages sent in the observer pattern. First, something happens which updates the state of the subject. When this happens, the subject sends itself the notify message. You can imagine that there might be many ways that a subject's state might change, so the notification is encapsulated in its own method, which can be called from any other method, or called from an outside object, if necessary. In the notify method, the subject sends an update message to all of its observers. The observers are then responsible for obtaining whatever state information is necessary for them to remain synchronized. To illustrate the observer pattern, I'm going to add a display which shows the XY location of the picture in our Picture Mover program. What I'll first do is program the display. I'm going to call this coordinates. And to do its job, it will need a reference to the movable picture so that it can register itself and obtain new state information. And it will need its own XY coordinates, which is where it will be located on the screen. Now, what it's going to display is the XY coordinates of the movable picture object. So it can either create and store a surface, which is those XY coordinates, each time it receives the update message, or it can store the coordinates and create a new surface every time it needs to draw. I think creating the surface only when it needs to update is probably more efficient, so I'll also store a surface. And then in the init method, it will initialize its reference to the moving picture and its XY coordinates. But then it will also send the attach method to the movable picture object. This is the standard message for an observer to register itself with a subject. Now, after we've created this class, we'll go back to movable picture and set it up to fulfill the role of a subject in the observer pattern. Okay, now the other initialization that needs to happen is it needs to create the surface with the XY coordinates. We'll use a pygame font to do that. A pygame font is a typeface and a size. So I've created a Helvetica size 30 font, and I use sys font, which means I won't package a font with the program. The program will look in the installed fonts for what we need. And then I create the surface by rendering the font, passing in the X and Y coordinates as a string, and then a Boolean for whether I want to anti-alias the font, and then the color. This means I need to know those coordinates, so I'll ask the movable picture for the coordinates. Which means, of course, I'll also have to set it up to allow access to that state information necessary for this observer to remain synchronized. So I'm going to draw that in white, since our background is black. Now our coordinates object has an initializer. It will also need a draw method, and that will be easy. It will just split its surface to the surface that is passed at its XY coordinates. The final method that I must write is the update method, which is the method that allows it to fulfill its role as an observer in the observer pattern. In the update method, we basically repeat this code from the initializer. We obtain the coordinates from the subject, the movable picture, and we render them to our surface. Then the next time we're asked to draw, which will be 30 times a second, the same as when the eclipse picture draws, we'll be drawing the correct coordinates. Now for the movable picture object to take on the role of subject in the observer pattern, it will need to maintain a list of observers, so we'll add that to its fields. And we'll initialize it to the empty list in the init method. Now, the list of methods that are part of the pattern are attach, detach, and notify. We will also have to write get coordinates so that our observer can obtain the state information it needs. I'll write those and come back. Attach takes a parameter, which is the object that wants to be an observer, and we simply add it to the list. Detach takes a parameter, which is the object that no longer wants to be an observer, and we'll make sure it's on the list and then remove it. And notify iterates through the list and sends the update message to each observer in the list. Get coordinates is going to return a tuple, which is the XY coordinates of the movable picture. The other thing we need to do is have the movable picture object send itself the notify message every time its state changes. And the only time its state changes is when it moves. So at the bottom of the move message, I've written self.notify. Most of that is pretty straightforward. Now, there is one other change I've made to the movable picture object, and that relates to pickling the class. We cannot pickle a surface, so the decision is, do we write a setState method for our coordinates class, or do we not pickle it at all? And I'm just going to make this simple and not pickle the list of observers. So I've modified the movable picture getState and setState to create a new list of observers and not write the old list out to the pickle file. That's a band-aid. If this were a system with a possible future, we'd need to think carefully about what needs to be pickled and how. But this will be fine for this small system, and I want to focus on the observer pattern and not pickling issues. Okay, so down in the picture mover class, which holds our event loop, we're going to add a coordinates object to the list of fields. And we'll initialize that from a parameter. And then we'll have it draw when we draw everything else each time through the event loop. Down in main, we'll actually create the coordinates object, and we'll do that after we either read the picture in from the pickle file or create it from defaults. And that's it. We create a coordinates object, which is an observer attached to the movable picture object. Each time through the event loop, we draw it, and every time the movable picture object moves, it sends itself the notify message, which sends the update message to coordinates, which causes it to get the new coordinates from the picture and render a new surface with the coordinates. Let's run it and see. Okay, and when it opens, we can see the location of the eclipse image at the top left of the screen, because that's where I put the coordinates object. And I'll press the arrow keys a few times, and we can see the coordinates update. And undo, of course, also moves the eclipse picture and changes the coordinates. Remember that undo sends the move message to the movable picture as well. This pattern is not too complicated. You maintain a list of observers in your subject object. When the subject object has a state change, it sends itself the notify message. In the notify method, it informs all observers that there's been a state change by sending the update message. And it has attach and detach methods so objects can add and remove themselves from the list of observers. An observer maintains a reference to the object with which it must remain synchronized. It writes an update message in which it obtains a state from the subject and updates its own state to remain synchronized. In this example, the state that the coordinates object must remain synchronized with is the XY coordinate of the movable picture, and what it updates is its surface on which it has rendered those coordinates for display. I recommend you try to recreate this example from the original movable picture code without referencing this video or the code unless you have to. Then you might try another enhancement based on the same state information, maybe a proximity alert, which flashes an alert on the screen if the movable picture gets within 10 pixels of a border. Once you can write code that implements the observer pattern, you're ready to move on.